Hello students, welcome to Dr. Shorab sir classes. So in this particular video we'll be solving this UPSC maths optional paper, and this is paper 2, and we are solving the paper of 2021. Okay, so in the previous video, if you have checked it out yet, so that you have seen that we have solved the question 1 to 5, and in this video we will be solving this question 6. So the part A is saying that solve the wave equation, where this wave equation is given a square, del square u del x square del to u del t 2 in this range 0 to L. So it's t greater than 0. The conditions are given: u of 0 comma t is equal to 0 and u of L comma t is equal to 0. So u of x comma 0 is 1 by 4 x of L minus x. So it is the L is the range, the maximum, and del u del t at t equal to 0 is also 0. Okay, so first of all, so consider this wave equation with the boundary condition. That is, it is okay. So this equation, it has been given. So this is equation number 1. Let us take. So it is x in the range L to 0. Okay. So this is equation 1. Okay, and we have t greater than 0, and the initial conditions are already given, the subject conditions, subject to the condition. So suppose, let us take u of x comma t be x of x t of t be the solution to the equation 1. Okay, so then if we do the derivative with respect to x and t, so del u del x, it is x prime x t of t del u del t x of x t prime small t. Similarly, if we do the second derivative, so it is x double prime of x t of t, and similarly it will be x x t double prime of t. Okay, so now if we substitute this equation, this expression in the equation 1, so it will be, so I'm writing it over here, so it will be a square x double prime of t of t, which is equal to x of x t double prime t, right? So if we take this, is x double prime by x is equal to t double prime by a square t. If we take this as minus of lambda, say, okay, so then we will have this x double prime plus lambda of x is equal to 0, and t double prime plus lambda a square t is equal to 0. So these differential equations will have this different solution corresponding to this different values of lambda. So we will take this, the case number 1, where lambda is equal to 0. So this lambda is equal to 0, so that is x of c1x plus c2, and t is c3 plus c4, Okay, so that the solution to this one, equation 1, solution to equation 1, so it will be u of xt c1x plus c2 and c3t plus c, right? So that is for lambda equal to 0. Then the boundary condition will lead to the trivial solution for e equal to 0. The boundary conditions leads to trivial solution, right? For this lambda is equal to 0. Now for the second one, this if we just take this lambda is equal to this minus alpha square. So let us take this lambda is equal to minus of alpha square, where alpha is greater than 0. Okay, so then we have x of this x will be c1 cos of h alpha x plus c2 sine h of alpha x, and t will be equal to c3 cos of h alpha t plus c4 sine of h alpha t, right? So the solution to the equation 1 will be u of x comma t. So this is gonna be this the x and t. So you can see that c1 cos h alpha x plus c2 sine h alpha x multiplied by c3 cos h alpha t plus c4 sine h alpha t, right? So if we, this boundary condition will also lead to the trivial solution for e equal to 0, same as this case for lambda equal to 0. So for lambda equal to minus of alpha square, we have the boundary condition will lead to 0 for e equal to 0. Okay, so in the next solution, if we get that, if we take this lambda is equal to alpha square, okay, where alpha is greater than 0, so here we will have directly the, as you know, the u of xt will be, this will be c1 of cos alpha x plus c2 sine alpha x multiplied by c3 cos of a alpha t plus c4 sine of a alpha t. Okay, so here in this there is a, so here it will be a and a, so here I'm just writing it, so c3 cos h a alpha t plus c4 sine h a alpha t. Similarly, after the u of xt, the solution will be c3 cos of h a alpha t plus c4 sine h a alpha t. So I have missed that a over part over there. So the solution to this, if for lambda equal to alpha square, the solution of u of xt will be this c1 of cos alpha x plus c2 sine alpha x multiplied by c3 cos a alpha t plus c4 a alpha t, so plus c4 sine of a alpha t. Okay, so if we use the boundary condition, that is u of 0 t is equal to 0 and u of l t is equal to 0, so then it will lead to the solution c1 is equal to 0 and alpha equal to n pi by l. Okay, so now the thing is that if we therefore the solution to this equation 1, it can be written as, after applying the superposition principle, okay, if we use the superposition principle, so we can write this as u of x comma t is equal to summation of n equal to 1 to infinity u of n, where this n equal to 1 to infinity, so it is a n cos of alpha pi n by l plus bn sine of alpha n pi by n. Okay, so that's gonna be t multiplied by sine of n pi l by x. So that is equation number 2. Now thus the solution given above by the 2 satisfies the condition, the boundary condition, okay, for u of the u of 0 comma t is equal to u of l comma t equal to 0, right? Now however, these have to satisfy the initial condition, that is we have this u of x comma 0 is equal to 1 upon 4 x of l minus x, so that is equal to summation n equal to 1 to infinity a n sine of n pi l by x. So that is equation 3. So therefore, taking on this t equal to 0, if we take t equal to 0 in this equation 2, then the right side of this, it will be the half range series. If t equal to 0, so it is the half range sine series. Okay, so then an can be evaluated by, if we do the evaluation for an, this an is equal to 2 by l integral 0 to l 1 by 4 x of l minus x sine of n pi n by l x of x. Okay, so if we solve this, so I'm just if we can solve this, so first step will be, so if we can do that, l can be written as 1 by 2l, because 2 and 4 will cancel out, so here it will be 0 to l lx sine of n pi l x dx, right, minus of 1 by 2l 0 to l x square sine of n pi l x dx right? So then we can do over here that if we simplify this, so it will be minus of l square by 2 of n pi cos of n pi plus l square by 2 n pi cos n pi, so it will cancel out, and we have here it will be 1 by n pi xl by n pi sine of n pi by l plus l square by n square pi square cos of n pi l x, that is 0 to l. Okay, so then we have only, if we solve this, so we will have this, it will be equal to minus of l square by n cube pi cube cos of n pi minus 1 and if we solve this, so it will be, if we this expression, if we do this 1 minus minus of 1 pi to the power n cube pi cube. So that is equation 4. So we have this condition, that this condition is del u del t of t equal to 0 is equal to 0. So this equal to, so this will have this del u del t at t equal to 0 is equal to 0, right? So if we use this in equation 2, so it will lead to 0 of 1 to infinity, sorry, bn a pi n by l and sine of n pi l by x. Okay, so now here it will be, you can solve this, it is bn is equal to 0, that is equation number 5. Therefore the solution to the equation 1 satisfying the boundary condition will be u of xt, u of xt, it will be L cube by pi cube summation of n equal to 1 to infinity, this is 1 minus of minus 1 to the power n by n cube sine of n pi l by x and cos of, it will be a pi n by l of t. So that is the solution to this equation number 1 satisfying the boundary condition. So you can see that this type of question may also come. So if you are well prepared with this, so you can attempt this, and you have to be this elaborative to get the answer to this question. So this is the solution to this particular question number 6a. So in the next video we will solve the question 6b. See you in the next video.